Pain. Who does like it? The one present it is important for our survival. Tells us to pay attention to our bodies and do something. Pain technically is an unpleasant sensory and emotional experience associated with actual or potential tissue damage. So let's know about pain and how the brain responds to it. Pain has an intensity, but different people experience it differently. Pain has characters also like sharp, dull, burning, or aching. Pain is a highly subjective sensation. Moreover, different people have varying pain threshold and tolerance levels. There are mainly two types of pain, nociceptive pain and neuropathic pain. Let's talk about nociceptive pain. Our body has nerve receptors that are always monitoring and responding to certain stimuli. There are chemoreceptors, thermoreceptors, mechanoreceptors, photoreceptors, and nociceptors, which fire signals only to indicate pain. Nociceptors are present in our skin, muscles, joints, bones, and internal organs. Nociceptors detect mechanical, thermal, and chemical threats. Let's take a case. Suppose there is a burning candle in front of you. You take your finger near the flame, you can feel the warmth. Your normal sensory receptors are sending signals currently. But if you bring your finger very close to the flame and keep it for some time for the sake of experiment, being too hot, you lift your finger soon. You now start feeling pain. Let's see what had happened. When you brought your finger very close to the flame started damaging the cells and you reached the nociceptive threshold. Then, the nociceptors in your finger started firing signals. These signals were then received by the spinal cord. The spinal cord, to prevent further damage, instructed your motor nerves to move quickly. It didn't bother to contact the brain since the situation needed an immediate response. Thus, your finger got saved from further damage. At the same time, the spinal cord sent information to the brain what had happened. The signal reached the thalamus from where it went to different parts of the brain. The brain analyzed about previous experiences, what had happened, and why. Your brain then made you feel pain, which stopped you from doing that again. Therefore, pain is completely made up by the brain, not by the damaged tissue. Psychological factors such as personality, beliefs, socio-cultural variables, and emotional reactivity can also influence the perception of pain. Neuropathic pain is the second type of pain. It isn't typically triggered by an event. Instead, the body just sends electrical signals to your brain without any reason. Instead of injury or damage in tissues, the nervous system itself becomes malfunctioning. It may be caused due to damage to nerve cells, diseases, infections, etc. People with this pain may experience shooting and burning pain. Neuropathic pain is often chronic, that is, pain persisting for more than 3 months. This may be caused as more and more pain signals are sent. The brain may decide that more protection is needed, so neuron cells may become more sensitive than before. Therefore, in some cases, even the light touches to the skin can trigger intensive electrical signals. The mechanism behind the experience of pain is very complex. We are only beginning to dive into the complexity of it. Until recently, we thought that glial cells were only providing support to the neurons. But we have found that they play a huge role in nociception and can also amplify the electrical signals. We also know that pain is not directly related to tissue damage. There can be an injury without pain and a pain without an injury. There can also be pain without an existing body part, like in phantom limb syndrome. in which a person who has an amputated limb might experience pain in non-existing body part now. So next time when you feel pain, just remember that there is a very complex process behind it and your brain is trying to protect you.